Dear students, today's topic is phase locked loop or PLL. PLL is an electronic module or circuit that locks the phase of the output to the input. Let us see the block diagram of phase locked loop. The first block is phase detector, second one low pass filter, third one is voltage controlled oscillator. The first block is phase detector. We have already covered this topic in the last video lecture, and the second block diagram is block is low pass filter. And what is the function of low pass filter? The function of low pass filter is to filter out the low frequency signal. And the third one is voltage controlled oscillator. Voltage controlled oscillator or VCO is an oscillator whose oscillating frequency varies in response to a control voltage VC. That means the input voltage is VC and the output oscillation frequency is F0. That means you can control the output oscillator frequency by varying the input voltage VC. Okay, output oscillation frequency is F0 and the input voltage is VC. You can control the frequency, output frequency by varying the input voltage VC. And let us see the difference between locked phase and unlocked phase. Our topic is PLL, that is phase locked loop. Then what do you mean by locked and unlocked phase? Okay, see the first example. Here the first example shows both the signals Vi of t and V0 of t are in same phase. And in the second example, which shows there is a phase error between these two signals Vi of t and V0 of t. The phase error is represented by delta phi. So the second example is called the unlocked phase. Okay, then what is the difference between locked phase and unlocked phase? Both the signals are in same phase. You can say it's a locked phase. And is there any phase error? You can say it's a unlocked phase. And our first block in the PLL block diagram is phase detector. And here see the phase error. Phase detector means you can detect the phase error. Delta phi is equal to 1 when Vi not equal to V0 and 0 when V1 is equal to 0. All of you are familiar with these conditions. That means XOR gate will give these conditions. And you can use XOR gate as a phase detector circuit. And the next one, I have already told you what is voltage controlled oscillator. Voltage controlled oscillator means the oscillating frequency F0 varies in response to a control voltage VC. We will see later this topic in detail. And simple PLL structure. Already we have seen phase detector, low pass filter and VCO. And what is locked condition? In locked condition, d by dt of phi in minus phi out is equal to 0. And in the unlocked state, V1 is equal to Va cos omega 1 into t, V out is equal to Vb cos omega 1 into t plus phi 0, and the V out is equal to Vb into cos omega 1 t plus phi 0 minus delta phi t. That is the unlocked state of the two signals. And this is the block diagram. I will give the explanation of this block diagram. Please listen carefully. The basic block diagram of phase locked loop shown in this figure. The main elements of the PLL are phase detector and a low pass filter and a voltage controlled oscillator. The phase detector is fundamentally a multiplier which generates the sum and difference of the two input signals. The free running frequency F0 of the VCO is determined by an externally connected resistor and a timing capacitor. When the loop is locked, the frequency F0 is directly proportional to an externally applied voltage VC called the DC control voltage. When an input periodic signal Vi of frequency Fi and VCO output signal voltage V0 or frequency F0 are applied to the PLL, the phase detector produce a DC or low frequency signal VE, which is proportional to the phase difference between the input signal VI and the VCO output signal V0. Here we are applying input signal VI and VCO output voltage V0. So the phase detector output will give VER, and when the phase sensitive signal from the phase detector is passed through the low pass filter, the high frequency sum component is filtered out. The low frequency difference component passes out of the filter and then amplified by the error amplifier A. This amplified signal is applied to the input of VCO as control voltage, which changes the VCO frequency F0 in such a way that the difference between F0 and Fi is reduced. If the two frequencies are brought almost identical by this feedback action, then the circuit is said to be logged. Once the log is achieved, the VCO frequency F0 becomes equal to the input signal frequency Fi with a finite phase difference phi. This is the working of PLL, and there are two terms, that is lock range and capture range, related to this PLL. Okay, and what is lock range? The lock range is defined as the range of frequencies over which the PLL system follows the changes in the input frequency. And the capture range is the frequency range in which the PLL acquires phase lock. That means capture range is always smaller than the lock range. See the lock range and capture range. Lock range is equal to 2FL, that is equal to, first one, FLL to FLU. Lock range lower portion and lock range upper portion. That is the lock range is equal to 2FL, FLL and FLU. And the capture range 2FC, that is equal to capture range lower portion and capture range upper band, FCL and FCU. Capture range is equal to 2FC, and capture range is always smaller than the lock range. Thank you.